Welcome to my video here on limit practice. So for my first question here, I have a couple of graphs that I want to find the indicated limits. So this first one I have on here, I want to find the limit as x approaches 0 from the left-hand side. So on the left-hand side, as we're approaching an x value here of 0, we could see that this function goes to a value of 1. So this is equal to 1. For the limit as x approaches 0 now from the right-hand side, this function also approaches a value of 1. So since the left hand and the right hand limits both approach a value of 1, the overall limit as x approaches 0 is also equal to, well, 1. For my second one, I have the second function. We want to find the limit as x approaches 1 from the left-hand side. So from the left, as we approach a value of 1, we could see that this function takes a value of 2 from this graph. Takes a value, of 3 from this graph. So this is equal to 3. Likewise, the limit as x approaches 1 from the right-hand side, it also takes that value of 3 again. So the overall limit as x approaches 1 is equal to 3. For my third one, as I move this down so we could get a better look at that, this one now, as we approach -1 now from the left, we could see it approaching now where this open circle here is, which is at a value of 2. For the limit as x approaches -1 now from the right, this one, you could see it approaching where this closed circle here is, which is at -3. But now for the overall limit as x approaches -1, my negative did not show up on this. -1, this function, since the left-hand limit is 2, right-hand limit is -3, this one does not exist. For my fourth one there on the bottom, the limit as x approaches -1 from the left, this one, as we're approaching from the left, goes to this closed circle this time, which is at a value of -1. The limit as x approaches -1 now from the right, this one's approaching this open circle, which is at a value of 2. So the limit as x approaches -1, left-hand limit is -1, right-hand limit is +2. This one also does not exist. So that's it for the graphing ones. I also have a couple of function-based ones, as we can see here. So my first one, though, we want to calculate these limits, if possible, of course. Limit as x approaches 0 of 3x squared plus x divided by 2x. And that numerator, the 3x squared and the x, they both share 1x. So we could factor out the x out of that numerator. So this is the same thing as the limit as x approaches 0 of, this will be x times 3x plus 1, all divided by 2x. And now we could just cancel out those x's. So this is the limit as x approaches 0 of, this would just be 3x plus 1 all over 2. And now we could pop 0 in. Popping in 0 makes 3 times 0 plus 1 divided by 2. So this would just give us a fraction of 1/2 for that one. For the second one, I have the limit as x approaches 1 of 2x divided by x minus 1. This one we can't factor anything. We can't take anything out. There's not much we can do. If we try to put 1 in, we get a 2 in the numerator divided by 0 in the denominator. All right, so this limit is going to actually not exist because we can't do anything to it, can't make it any nicer, and it just gives us 1 over 0, and that's 2 over 0, excuse me, and that's not good. For the third one, limit as x approaches -1 of x squared plus 4x plus 3, all divided by x plus 1. So this one we could factor that numerator. So this is the limit as x approaches -1 of the x squared plus 4x plus 3. That factors to be x plus 3 times x plus 1, all divided by x plus 1. And then these x plus 1s, nicely, they cancel. So this gives us a value. Well, this changes our limit to be the limit as x approaches -1 of just x plus 3. So let me actually make that slightly more readable. It's a 3 there. There we go. The limit as x approaches -1 of x plus 3. So we could pop in that -1 now and get an actual number. So in our case, that's going to be -1 plus 3. So this gives us a value of 2. For my fourth one, limit as x approaches 2 of x plus 1 divided by the square root of x. Nothing's stopping us from putting 2 in here. Nothing cancels. We can't really manipulate that function in any shape or form, but we can put 2 in there. So this will make 2 plus 1 divided by the square root of 2. So that denominator doesn't simplify to make anything nice. So this will just be 3 divided by that square root of 2. For my fifth one, the limit as x approaches 1 of the absolute value of x minus 1 divided by x minus 1. So for that one, we do need to do actually a little bit of extra work here before we say what that one is. Since due to the absolute value, we have to separate out the left hand and right hand limits. So let's start with the left. This would be the limit as x approaches 1 from the left of, since we're approaching 1 from the left, right? This function then is actually going to take on, since we're approaching it from the left, it's going to be taking on negative numbers. So we can actually drop those absolute value bars. This makes negative x plus 1 divided, x minus 1. It'll be helpful if this actually erased when I'm erasing. There we go. So this is the limit as x approaches 1 from the left of negative x minus 1 divided by x minus 1. Those x minus 1s cancel. So this is just simply the limit as x approaches 1 from the left of -1. And that just gives us -1 since there's no x in there. Likewise, the limit as x approaches 1 now from the right. We could drop those absolute value bars again, and this time it takes positive numbers. So this would just be x minus 1 in the numerator, x minus 1 in the denominator. Again, those just cancel. So this makes the limit as x approaches 1 from the right of just the value of positive 1. And that just gives us a value of 1. So -1 and 1, since there are two different values for the left hand and right hand limits respectively, this one also does not exist. For my sixth one, limit as x approaches 5 of x squared plus x plus 1 all divided by 2. Even though we can factor that numerator, that's not going to cancel anything, and there's nothing really stopping it from taking a value of 5. So we can plug 5 directly in there. This makes 5 squared plus 5 plus 1, all divided by 2. So 25 plus 5, that makes 30, plus 1 is 31, divided by 2. That's a fraction. I'll just write it as 31 halves, or this would be 15.2 as a decimal. Let's say 15.5. We're talking about half. 15 and a half, 15.5. And then my 7th one there, I have the limit as x approaches 2 of the square root of x plus 1 divided by x squared. Again, can't cancel anything. Nothing stopping us from putting 2 into that limit. So this one takes the square root of 2 plus 1 divided by 2 squared. The numerator makes nothing nice. This is the square root of 3 divided by 4. Let me know if you have any questions or concerns. Thank you.